In this video, we will do a virtual visit of a biomass plant. This is our plant, and we will recognize the different elements that compose a biomass plant using this aerial image, identifying the different elements that compose a biomass plant. First of all, this plant is located in the south of Spain, and the fuel is olive marc. In Spanish, it's called orujillo, and this fuel comes from the process to produce oil from olive. This is the waste material that comes from this process, and it's a very good fuel because it has an interesting lower heat value. See, first of all, that we have three parts in the warehouse. Is this first part is the external warehouse. Second one is the covered warehouse. Yeah, and here is located the reservoir for 1 day. It's really it's not for 1 day, it's for 2 hours more or less, and this material is prepared for the consumption, for the immediately consumption in the boiler. And we will see, first of all, here you can see this different color of material. This is the same material. Probably the plant has some problems because it's not normal to have all this amount of material near of the plant, but probably there is some problem, and the fuel is accumulated near of the plant. See, normally the fuel is accumulated here or here, but after mass goes inside of this building. This building, see that has no wall, only has roof, but no wall. Is in order to allow the fuel could be dry in a natural way. And after that, see that here in this area we accumulate a little amount of fuel. See the big amount of fuel that we have in all the surrounding of the plant. Here we have 2 conveyors. The 2 conveyors we need for the plant only one. The second one is in standby. If we need, we use it, but normally we need only one to fit or to put the boiler at full power. These elements over here are for the consumption of other fuel different to this one. Remember that a biomass plant is designed only for a fuel, but normally sometimes it's necessary to use a second one. Warehouse, conveyor, and after the conveyor we have the little warehouse for only a couple of hours, and here we have the boiler. The boiler normally in a biomass plant is divided in 2 sections. One, the first section is the furniture, and the second one is to recover the part to recover energy. See, is a water tube boiler. See the 2 parts, this part and this part, both of them compose the boiler. Here is located the furnace, and the furnace has the main equipment of the furnace is the grill, and the grill, the biomass come in, goes in and put on fire the biomass, and liberate the thermal energy contained in the biomass. After that, here in this part, the wall of all the furnace are called a water wall, and there in this part is located the evaporation area. And there in these tubes that compose the wall, the water is evaporated, and after that there in the upper part of the boiler are located the superheater, and the steam is produced there in the water tubes, goes to this drum, and after the drum, the outlet of the drum is connected to the superheater, and after the superheater goes to the steam turbine. In this case, the steam turbine is located out of this area. There, then we have the grill, we have the water wall, the evaporator section, the drum, and the superheater. But here, in this area, we recover the energy contained in the flue gas, and there first we preheat the water till the evaporation temperature, and after we preheat the air, the combustion air. Then this is the recovery section, this is the furnace. After that, the smoke goes over this tube, and there is different section for filtering the smoke. It's in order to avoid that the solid particles goes out. In this case are electrofilters. One important element of the plant is this fan. This fan suck the smoke, provoke a low pressure inside of the boiler, and allow the circulation of the smoke till the stack. We can see that the height of the boiler is very high. Here, in this area, is located the steam turbine in this building. In these pipes takes the conduct the steam from the boiler to the steam turbine, and the steam turbine is located here. This is an aero condenser. After the steam goes to the steam turbine, and after transfer the potential energy of the steam turbine into electrical energy, the steam that goes out, the outlet of the steam, goes over here and condensate using this aero condenser. In this case, the plant does not use a cooling tower. Is more often we have a cooling tower than aero condenser, but in this case there are no water near of the plant, and they prefer to use an aero condenser. The aero condenser is very, very high because the power of the plant is around 15 megawatts. See the size of the aero condenser. There are at least 4 sections with 4 ventilators, very big ventilators. And now we can see again the different part of the plant. See the warehouse, see the conveyor, the boiler, and the electrofilter. And see here the fan to suck the smoke, and here are located ventilators to clean the electrofilters. can see better here the drum, and this is the silencer for the safety valves. See that the water steam cycle has different elements. One of the main elements of the water steam cycle is the feed water tank. In this feed water tank, the water, before goes into the boiler, suffer a process to degasify the water, to eliminate the oxygen and the CO2 that we can have here in the tank. And in this part here are located the feed water pumps. These feed water pumps increase the pressure of the water before to introduce it in the boiler. Here we can see the auxiliary fuel is only to start the boiler. We use diesel, and the plant has burners that use diesel. This building are located the steam turbine. The steam goes over this pipe rack, over this pipe, goes in, transform the potential energy contained in the steam into first mechanical energy and after electrical energy, and the outlet is this pipe. The outlet of this pipe goes in the air condenser and condensate the steam. Probably here we can see better the steam turbine building that is located here, and the connection between the boiler and the steam turbine is another circuit, is the water steam cycle, and the water steam cycle is composed by 3 circuits. One of them is the condensate water that come from this point, the air condenser, to the degasifier. All the element that goes over this in this line that come from here to here is the condensate circuit. After that we have another water circuit, is the feed water circuit, composed by the feed water tank plus the feed water pumps. And after the steam, the circuit, the pipes that conduct the steam from the boiler to the steam turbine goes over here. In some point, I don't see very well, but in some point there is a bypass valve. If the turbine is not operating, the steam can go directly to the air condenser. In this building are located normally the BOP, the balance of plant, the rest of the equipment of the plant. For example, the compressed air is produced here, and the water treatment plant produce water of very high quality, demi water, is produced here. The firefighting system is located here normally. All these elements that are here in this building are the auxiliary system or balance of plant. See the size of the plant. Even considering that the plant has only 15 megawatts, for 15 megawatts we need an area around 3-4 hectares is the total size. But from this point, we can recognize very well the different part of the biomass plant. One of them is the warehouse. See the big amount of olive mark of the fuel that we have accumulated here around the plant. This is the covered warehouse, the conveyor, the boiler. The boiler is composed by two parts, the furnace and the recovery heat part, and the area to filter the smoke, the flue gas. The balance of plant, the steam turbine and the building of the steam turbine, and the aero condenser to condensate the plant. There are interesting questions to solve. For example, why it is necessary to condensate the steam. You can ask yourself why it's necessary to condensate the steam, why it's necessary to cool the steam if we are going to heat again the steam a few minutes after. There are others question that you can ask yourself. For example, why? Which is the reason, the main reason? Because the turbine, the outlet of the steam turbine is under vacuum. Or why it is necessary to have this big element. And what happened, for example, if the normal efficiency of this plant is around 25%, that means that from the energy contained in the fuel, we transform in electrical energy only 25% of this energy. What happened with the rest? What happened with the 75% of the energy? Interesting question, but probably we can solve in other video.